So good morning, everyone. Once again, welcome to Physics by Physics. And in this C.T.P series, we are going to take questions related with Laplace and Poisson's equation. That will be the part of electrostatics. So we were discussing the electrostatics part. So next topic is Laplace and Poisson's equation. So we will see which type of questions may be asked related with this particular problem. So let's see. So again, we are taking questions from our QIP file, and in this we will only take one-dimensional case of Laplace and Poisson's equation. Three-dimensional case, we have to use the special techniques, so that we will take separately. So let's see the questions. So as you know that E is, what is divergence of E? Divergence of E is given by divergence of E is rho by epsilon. This is Gauss law, differential form of Gauss law. And you also know E is equal to minus of gradient V. If potential is given, how to find the electric field? And if you substitute E here, then you will get, this will give you divergence of a gradient will give you del square. So this will be minus rho by epsilon naught. This is called as Poisson's equation. This is called as Poisson's equation. Now, if in some reason, if charge density rho is 0 in some region, then you will get that del square V is 0. So this is called as Laplace equation. So we are going to take some questions related with Laplace and Poisson's equation. So let's see question number 1. Try to solve. So question number 1. Let's see question number 1. The scalar function phi satisfies the Laplace equation gradient phi. So phi is like a scalar potential. So it means it is given that del square phi is 0. So this will give you divergence of a gradient phi will be 0. So divergence of a gradient will be, divergence of a gradient of a scalar function will be 0. And then this will give you, when this condition will be satisfied, when gradient phi is some constant value. So when gradient is constant, what will be curl of this value? Curl of a constant is 0. Curl of a constant will be 0. It means when you will get del square phi is 0, it means gradient of function phi, scalar function phi, divergence also curl of a gradient, that will be 0. Has for a scalar function psi that satisfies the Laplace equation, what should be the gradient phi? So its grad divergence will be 0 and its curl will be 0. So it's a 0 curl and 0 divergence. So answer for this particular question is option C. 0 divergence and 0 curl. Clear? Chalo. Now see next question. Question number 2. Try to solve question number 2. So see, question number 2 is the electrostatic potential V as a function of xy in free space where charge density will be 0, where the charge density 0 is given by this relation. And it is also given that x component of the electric field Ex is 0 and potential V is 0 at the origin. So what will be function Fx? So see question number 2. So it is given that Vxy for e power 2x plus fx minus 3y square. Since rho is 0, so this will give you del square V will be 0. It is also given that Ex at origin is 0. X component of the electric field is 0. And potential at 0, 0 is also 0. So from the given information, you have to see what will be the function fx. So let's apply these conditions. So we will take when del square V is 0, del square V is 0. So it is function of xy. So you will get del 2V del x2 del 2V del y2. This will be 0. So let's differentiate with respect to x. So what you will get? Differentiate it twice. So 816 e power 2x plus f double dash x. This will be 0 and this will give you minus 6 is equal to 0. This will be the first equation. Now, what is the electric field? E is minus of gradient V. So what will be Ex component? Ex component will give you minus del V by del x, because you have to put Ex is equal to 0. So this will give you minus of 8 e power 2x plus f dash x, and this will be 0. This is partial derivative. So if you are differentiating with respect to x, y will be constant. Okay? So now, since Ex00 is 0, so this will give you what? Minus 8 into 1 plus f dash 0 is equal to 0. So this will give you f dash 0 is minus of it. F dash 0 is minus of 8. Because we have to solve this differential equation, and if you solve it, you have two things that you have to find: values of f dash and values of f0 also. Now since potential is also 0, so this will give you what? 4 plus F0 minus 0 is 0. So F0 is minus of 4. This is the value of F0. Now let's solve this equation to find the value of Fx. So what you will get, let's see this equation. Now let's call it as equation 1. From equation 1, what you will get? If you integrate equation 1, let's see, from 1, you will get F double dash X is 6 minus 16 e power 2x. If you differentiate it with respect to x, what you will get? This will give you f dash x. You are integrating with respect to x. So this is 6x. And this will give you what? Minus 8 e power 2x plus some constant c1. Integrate with respect to x. So this is x. This is e power 2x by 2. So this becomes 8. Integration constant is c1. And we have already calculated the value f dash 0. So since f dash 0 is minus 8. So this will give you minus 8, 0 minus 8 plus C1. So C1 is 0. So it means f dash x becomes 6x minus 8 e power 2x. If you further integrate it, this will be x square by 2. So this is 3x square minus 4 e power 2x plus C2. This value will be this will give you fx is 3x square minus 4 minus 4 e power 2x plus C2. And again, since f0 is minus 4, so this will give you C2 is 0 because this will cancel out. So finally, fx will be what? 3x square minus 4 e power 2x. So option D is correct. Option D is correct. So answer is D. Option D is correct. Is it clear? So note it down. So now we will see next question. Just see question number 3. So electrostatic potential in spherical polar coordinate is given. This is the electrostatic potential. Just see, electrostatic potential is phi r, phi naught exponential minus r by r naught. Where phi naught, r naught are a constant, then the charge density at r is equal to r naught. You have to find charge density at r is equal to r naught. 4 options are given. So let's see. Try to calculate. So, question number 3. Potential is given and you have to find charge density. So you have to use Poisson's equation. Charge density will be given by charge density rho is minus epsilon naught del square phi. And what will be del square phi? In a spherical polar coordinate, let's first find del square phi. So this will be r square del r square del phi by del r. Must remember the formulas in Cartesian, spherical, polar, and cylindrical symmetry. Whether it is gradient, divergence, curl, Laplacian, you have to remember those formulas. Only then you will be able to solve. If you don't remember how to write del square V in a spherical polar coordinate, you can't solve this question. So first thing is, you should remember this formula. Now what is del phi by del r? So this is 1 by r square del r square. Now if you differentiate with respect to r, what you will get? You will get first phi naught exponential value, and then you will get, if you differentiate this exponential, you will get minus 1 by r naught. So this is del phi by del r, phi naught here. This is phi naught because phi naught is constant. So now what you will get, let's take, you are taking, if you are taking minus phi naught common, so you will get, this is minus phi naught by r naught is common here. 1 by r square, and you will get del r square exponential minus r by r naught. So it's a matter of calculation. So this will be given by minus phi naught by r naught 1 by r square del, let's differentiate it. So differential of first into exponential minus r by r naught plus r square exponential minus r by r naught into minus 1 by r. This will be the value del square phi, but you have to find del square phi at r is equal to r naught. So what will be the value? Del square phi at r is equal to r naught is given by minus phi naught r naught 1 by r naught square. This is twice r naught exponential power minus 1 because r is equal to r naught. And then you have minus r naught square exponential minus 1 by r naught. So this becomes minus phi naught r naught cube, and this will be, this r naught will cancel out. This is r naught e power minus 1. So that will give you minus pi naught by E R naught square by E R naught square. And then what will be charge density rho? Charge density rho is minus epsilon naught del square phi at R is equal to R naught. So this is epsilon naught pi naught E R naught square. So this will be the charge density at around point R is equal to R naught. So which option is correct? Option A is correct. So in this case, option A is correct. Is it clear? So you should remember the formula and then how to apply the Poisson's equation and then you should calculate it. ठीक है? चलो. So option A is correct. Now see question number 4. Question number 4. Try to solve question number 4. So let's solve question number 4. So in this question, in a coaxial cable, the radius of the inner conductor is 2 millimeter and that of the outer one is 5 millimeter. The inner conductor, this inner one is at potential 10 volt, while the outer one is the grounded. The value of the potential at a distance 3.5 mm means greater than 2 mm and less than. So in this region you have to find what will be the potential. So there are now no charge, it's a charge free region. So you have to apply the Laplace equation and you have to solve it in cylindrical coordinate system because it's a coaxial cable. Cable or wire has cylindrical symmetry. So let's see how to solve this question. So question number 4. So potential will be in a charge free region del square V will be 0. So you have to use Laplace equation. Now how to write this in cylindrical coordinate system? So this is in cylindrical coordinate system. This is 1 by R del R R del V by del R is 0. So this is del square V in cylindrical coordinate system. So how to solve this equation? This will give you R del V by del R is equal to 0. So if you integrate it, this will give you R del V by del R. This will be some constant A. I am taking A to be constant of integration. So let's integrate it with respect to R. And then you have del V by del R is A by R. If you further integrate it, V as a function of R will be given by A ln R plus some new constant B, because it's a second order equation. So you will get two constants A and B, and two conditions are given. Two boundary conditions are given. One at R is equal to 2 mm, 10 volt, and R is equal to 5 mm, that is 0 volt. So let's see, when R is equal to 2 mm. So this potential is 10 volt. So this will be 10 volt and A ln 2 plus B. And next question is, when R is equal to 5 mm, potential will be 0. A ln 5 plus B. Now you have to solve these two equations for A and B. So let's see, from these two equations, if you subtract this, so this will give you 10 is A ln 2 minus A ln 5. So A will be given by 10 by ln 2 minus ln 5. So this will be the negative value, and if you calculate this, this will be minus 10.86. You have to check the value. This is ln base E, log base E. So ln 2 minus ln 5, and 10 by this value is minus 10.86. And then B is given by minus A ln 5. So this will be 10.86 ln 5. So if you calculate the value of B, this value is 17.39. 17.39. So you have to calculate constant A and B, and then you should find the what will be V at 3 point, V at R is equal to 3.5 mm. So this will be A is minus 10.86 minus 10.86. Then you have ln 3.5 plus B is 17.39. Now check the numerical value. A ln 3.5 plus B. So if you check the numerical value, I think this value is approximate value is 3.8 volt. 3.8 volt. So it's a matter of calculation, and I have discussed the case of one dimension only. For 3-dimension case, we have to use the special techniques, so that we will discuss separately. Clear? So in 1-dimension case, you have to focus on these questions only. Okay? So just remember Laplace equation, Poisson's equation. You should remember the formula in different coordinate system. you will be able to find whether it is charge density or potential in different region. ठीक है? चलो फिर. So in next lecture, we are going to take from the polarization part. So we will take electric dipole and electric polarization. So tomorrow we will focus on electric dipole and polarization of the material. So we will meet you tomorrow, same time, 11 a.m. 11 a.m. Okay. Thank you.